Sorry, I just realized that my recorder only goes for 15 minutes. I'm going to have to do this in smaller snippets. Let's see if I can find where I was. There we are. So I just got done saying all dogs are hairy represents this. P represents all hairy things. S represents dogs. They're in here. All dogs are hairy things, but not all hairy things are dogs. Okay. There's a little different relationship over here. All S is not P. All P is S here, but all S is not P. Okay. So there are some things that are S that aren't P. This is a some is not. Some S is not P. Remember, some in logic means 99%. For it to be all, it has to be 100%. 99% is still some. Even though it's a big bunch, it's still some. Here's the same thing. Here's S over here that's not P. Here's P over here that's not S. But here's S and P that are the same. So some S is P, some P is S, but some S is not P, some P is not S. That's the relationship of subcontrary. Okay, they're contrary because they're different colors, but they can both be true at the same time because they overlap. But they're also it kind of goes both ways. And then also here's no S is P, okay, or all S is not P. You can put it a lot of different ways. Not any of S is P, however you want to put it, but it all comes down to the logical way of putting it. No S is P. We call it an E, and we call this an O. Sorry for the graphics are bad, I think, but no S overlaps. But this is also some S is not P, because if no S is P, then it just stands to reason that some S is not P. It sounds weird, but that's the way logic works there, okay? And remember, this is a contradiction. So if there's overlap, there's subimplication or subcontrary. I didn't put that here. Subcontrary is down here. Where there is space between the colors, there is contradiction. Where the relationship between all and no is called a contrary. The difference here, I'll explain more in a minute, but contrary is like when you say all or nothing. Okay, contradiction doesn't have to be all or nothing. It just means there's something not adding up. And then the relationship between some and some are not is called a subcontrary. Here are the rules. A subimplication implies that if the universal is true, the particular is true. The subcontrary says both can be true and both can, but both cannot be false. Okay, they both cannot be false, but they can both be true. The contrary says both cannot be true, but both can be false. Well, think of the phrase all or nothing. You always do that. Well, that's a hard thing to prove. You never do that. That's a hard thing to prove. They can both be false. But you say you always do that, and I say, well, wait, I didn't do it yesterday. Well, now I've shown that they cannot both be true, right? Okay. And that's what a contradiction does. And this is one of the first rules of contradiction. We're going to define it better, but this is the rule. A contradiction says both cannot be true and both cannot be false. Or one or the other has to be true. If you have a relationship of statements that's contradictory, one or the other has to be true. If I said something like, all dogs bark, and you said, well, my dog doesn't bark. Well, but he can bark. He's a dog. But if I said all ducks quack, and that's not a true statement, by the way, because some ducks don't quack. They just whistle or chirp or do other things like other birds do. So all ducks quack and some ducks do not quack is a contradiction. Only one of those can be true. Either all ducks quack or some don't, but they both can't be true. And it is not the case that all ducks quack. Some ducks do not quack. Some ducks do, some ducks don't. Okay? So, subimplication, all dogs bark implies some dogs bark. Some cats are black and some cats are gray. Okay, that can both be true. No dogs are cats, that's a contrary. Okay? That no dogs are cats implies that some dogs are not cats. Now remember, that does imply some dogs are. We're not saying anything about that. We're just saying it implies some dogs are not. That's more for working out formulas than other things. But it's very easy to take the idea that some dogs are not cats and say, well, therefore some dogs are cats, and that sounds weird. But that's not the case. There's no relationship there. But if I say some dogs are not cats, that contradicts that all dogs are cats. But we know no dogs are cats, so that's that's also a contrary relationship. But we would probably just say it contradicts. And no cats are fish contradicts that some cats are fish. The relationship, and that's what you're going to see on the square of opposition here. The universal affirmative contradicts the particular negative. The universal negative contradicts the universal or the universal particular here, particular universal. Those are the contradictions, okay? They're at those angles. Up here, A and E, contraries. Here, they call it subaltern. It's another word for subimplication. If A is true, then I is true. If E is true, then O is true. And down here, if I and E, they could be either false or true, but they both can't be false, okay? They can both be true, but they both can't be false. Or it's not a relationship, all right? That's what it's trying to say. All right, so we're going to take a break here. You can look at a blank screen. And I got to see how much time. I'm at 6 minutes now in the second recording, okay? Certainly, if you have any questions, you can email me. And try to explain a little further. Okay. Everybody put everything in place. And we're taking off again. Okay, so what we start doing with these claims now are making syllogisms. The word syllogism just literally means with logic, with logical things, okay? And what a syllogism does is it places at least two claims as premises to deduce a conclusion. So the relationship of the two claims implies something else. The conclusion follows from the premises. And this is the classic, all humans are mortal. Socrates is a human. Socrates is mortal. Okay, that follows from that. If all humans are mortal and Socrates is a human, then he's in the category of mortals because all humans are mortal. So he is mortal. That's what it's saying. All right. That's a basic syllogism. That's an A syllogism. They're all A statements. This is the most basic syllogism there is. What you're going to find, I'm not getting into everything because we'd have to have a class on logic that would last a semester to get into everything. But 90% of what you need to know about syllogisms are in the ones I'm giving you. The rest of it is just more for like practice logic and mathematical things and things like that. Not so much so you can evaluate things. The principles I'm giving you here will cover about 90% of what you're going to be dealing with in your class. All right. So then there's bad logic. I like this. This makes sense to me. Syllogism means with logic. Here's syllogismos, with logic, logical. Paralogismos means beside logic, or something that's illogical, invalid, or fallacious. This is the word that Aristotle uses in his books about fallacies, invalidity, and he just calls it bad logic, which I like. And I like to say inside your brain you have a syllogizer. A logical function, okay? And what we're doing is we're fine-tuning our syllogizer so it doesn't do this and it only does this. There's going to be some ways you're going to think it's here, and that's why this corrects this, okay? And it's interesting that Paul uses this in Colossians 2:4, this relationship, if you want to look that up, okay? Anyway, so an enthymeme is a syllogism with one element missing, okay? We call this an enthymeme. Big deal for Aristotle in his book on the rhetoric. Here's just a classic example. Let's not go fishing. It just rained. Okay? That's an argument not to go fishing. I give a reason, because it rained. There's an implied because or since between the two claims. The last is not really a claim. It's a conclusion. It can be a claim, but it's more like a command here. Let's not do that. Okay? So what you got to remember when you have enthymemes like this, what comes before a because is a premise, and what comes after a because is the conclusion. So if you go back here, it's going to follow this form with Aristotle or Socrates, premise, conclusion. This helps you set it up so you can see what's going on. So when you set it up, there's an implied premise, and I call it an implied commonplace, but we can debate it. It goes like this. And this is how you would kind of break it down into real logical form. All times it rains are bad fishing times. That's kind of the implied premise I'm working off of. All now is a time it has rained. All now is a bad fishing time. put in the vernacular, let's not go fishing, it just rained. Okay? But I've got this sort of implied premise that when it rains, it's not a good time to go fishing, or more specifically, all times it rains are bad fishing times. That's the way you put it in logical form to see what's going on. Now, we can question whether this premise is true. Okay? But given this premise, this all follows. And here's the syllogism. All R is B, all N is R, therefore all N is B. You see the connection right here. If all R is B, and all N is R, so in a sense you can do, if N equals R and R equals B, then N equals B is kind of what's going on here. But logic puts it a little bit out of order, and there's reasons for that. But that's a syllogism put in symbolic form. All R is B, all N is R, therefore all N is B. Okay. Now, that's a valid argument. You may not be persuaded, and you'll see why in a minute, but it is a valid argument. Okay. So enthymemes. I didn't put anything here. Another break. Okay. Enthymeme just means that something's inside the person, and you're assuming that the hidden premise is something they'll kind of bring to the table themselves when you say what you say. So you don't state it out loud. It's for brevity. It's also for a persuasive value, because you're bringing them into your argument sort of subjectively, is the way Aristotle saw it. Okay. So when we go back to the A's and E's back here in the thing, remember I said there are A's and E's. Let's see, where's the square? So you got A, E, I, O. And these are, you can put these statements in a relationship and make a syllogism. So you're going to have 3 letters, but just a fun little thing here is that old MacDonald had a farm, and on his farm every syllogism was valid. Okay? And here's some, really, it's because of subimplication. But anytime you have E-I-O as the form of the syllogism, like this one is, E-I-O, it's going to be valid. So, have a little fun with that, okay? Every time you have a syllogism that has an E, an I, and then an O conclusion, you're going to have a valid argument. And if we were doing a class, we'd get into why this is true. But you can just remember anytime you have an EIO, it's valid. It's just a fun little thing I do. Because most stuff we're going to deal with aren't going to be dealing with arguments like this. In fact, this isn't really a strong EIO arguments are not strong arguments, but they are true. Okay, and valid. Okay, so I brought up the relationships again to remind us of that. A, I, E, and O. And the main reason EIO is valid is because it always implies a subcontrary between E and O. Always. And the middle premise is an I, and both of those can be true at the same time, so you don't have a contradiction. Okay, if you can follow that, great. If you can't, don't worry about it. So validity has to do with the form of the argument, not the truth of the argument. And people miss this all the time. The press is awful about using logical terms out of place. It drives a guy like me who's a nerd crazy. But I can only throw stuff at the TV so many times, and nobody hears it anyway. But validity has to do with the form of the argument, not the truth of the argument. So here is a form. All A is B, all C is A, all C is B. That's the valid form. That's the Socrates things we just looked at. This is an invalid form. All B is A, all C is A, therefore all C is B. Okay? Now that may look, as we look at it, well, wait a second, it's kind of the same thing. But because of the form, you can't draw the conclusion from the premises. And I'll give you an example of this in a little bit. Okay, but this is invalid, not because of anything it's true or false, but just because of the form of where the B's and the A's and the C's and the B's are. That's all I want you to see here. That's invalid because of the form, not because of the truth. And if you're reading the book, The Love of Wisdom, they aren't as clear on this as I'd like them to be. Okay? But I think hopefully you'll see this afterwards. So here's a valid argument. Okay? All places where there is cheese, there are mice. The moon is made of green cheese. There are mice on the moon. That is a valid argument, but it's not sound. And unsound means it's not true. Now, of course, every premise here is false. There are places where there's cheese, there aren't mice. Now, I know the mice like to get into that, so that may be the most true premise of all of them. That mice like cheese anyway. They like to go where there's cheese. But the moon is made of green cheese, obviously, is wrong. It's made of blue cheese, right? We all agree on that. That's just a common